Hey everyone, welcome back to this second tutorial of this Expo series for Python programs. So in this tutorial, we're going to study about the data models and Dunder methods, special Dunder magic methods, you can say. So before starting that, I would recommend that you just follow this documentation here, and the link is docs.python.org/3/reference/data model.html. I'll be giving this link in the description below. So what basically are the special methods? So special methods or the Dunder methods, you can see like this underscore underscore new underscore init underscore delete and so on. These basically are used for function overloading. So let me just explain it to you what I meant by that. Let's see guys, that basically you have to find two variables, and in that variables you have x is equals to 10 and y is equals to 20. Okay, so now if I call this that print the value of x, you gotta notice this x plus y, and if I go on, okay, sorry, yes, you can see that basically the value of 30 is being printed over here. So this plus operator basically it uses a Dunder method, special Dunder method called add, which goes like double underscore add. It goes something like this. So whenever you call this plus sign on any of the two operands, then this add Dunder methods gets activated, and basically you can see the result through it. So this Dunder methods basically they work behind under the hood. Basically they work under the hood and they are not visible to you, but they work in the Python scripts. And if you want to overload them or override them, then basically what you can do is create a class, and then in that class you can define special Dunder methods and how you want to use it. So let's get started with it. So I'll just create a class person, and then I'll create this first Dunder method, which goes like init method, init method. I'll be giving self comma a comma b, the two of them which I want to add, and then I'll be saying that self dot a is equals to a and self dot b is equals to b. And now for calling that calling that plus operator, we'll be defining the add underscore add Dunder method and override it. So I'll say def add, and I'll just basically self. Okay, and now what I'll do is I'll just basically return the value for it with some changes. So what I'll do is I'll use the f string, and I'll say that I want to return something like this. The addition is, and you can say something like this, and you can say self dot a plus self dot b, and that's it. So now if you create the object of the class, let's say that I create an object d is equals to person, and I give value of 10 comma 30, and then I call print d dot add. I call this, then, and if I run it, okay, person takes no arguments. Okay. So error was here. It's not an argument, it's just basically a class. Let me just first of all clear this for you. Okay, so now if I print it, person takes no arguments, and okay. So now if you call this at underscore underscore at Dunder method, and in this command prompt, just show it, and you can see that basically the underscore underscore at Dunder method has been override. And I wrote some other things in it to say that the addition is 30. Before it was just showing me 30. So that was using the Dunder method itself. So now let's say that you want to use the plus operator. So for that you need to do some changes in it. First of all, we'll delete this b argument, and instead of the self dot b, we'll say other dot a. So I'll explain it in a bit to you. And this, and here I've created one instance of the person class, and let's say that I create another instance or object of the person class, and I give the value of 20, and I say, and this print I call c plus t. So what I did, why I use this other here, so I use this other argument in my underscore underscore add Dunder method, because I want basically to add two arguments. So let's say that you want to add two arguments of the same class. So first of the same class, but they have, but the instance is but they have but the same class is has the different instance. So this self dot a, it represents the first instance, and this other dot a represents the another instance. So let's say so that's why I use this other argument over here. So let's say that you want to add three numbers. So you just say that instead of other, you can say that second and third, and for that I'll just use second dot a. Okay, sorry, second dot a plus third dot a. And now I'll create another instance over here, and that's the third instance, which goes like, let me give 50. So now if I print c plus t plus e, so okay, the third dot a, so that's the second third a. Okay, so this particular traceback was there because the special plus operator here, it can add only the two operands for now, and for overriding it, you just need to create another instance over here and then write some another arguments in this add only, and then you can just override it and add as much arguments as possible as you want. Okay, so that was all about the add Dunder method. So let's move on, and let's talk about the multiplication method. So what I'll do is okay, sorry, what I'll do is just and the multiplication operator, which is this, it goes it has the Dunder name as mul. So mul, and it goes like self and then other. Okay, sorry, okay, other. Why I'm giving a new parameter over here, other parameter, I'll just explain it in a bit. Sorry, it will be mul. And now let's say that you want basically basically check for a special data type only. Let's say that you want to multiply a number with an integer number only. So for that we will say that if type of other is not none, sorry, it's not int. So what I'll do, I'll raise an exception in which it will show that the data type, sorry, the number should be integer, and in the else part we'll say just return self dot a. So it goes like self dot a is equals to self dot a multiplied by x, oh sorry, it will be other. And now let's just delete this d, and we'll say that c multiplied by, let's say, 2. So if you run it, okay, if integer is not, it's showing me none. Okay, yes, I haven't returned anything in this multiplication method. So with that, you should basically now return self dot a. Yes, now showing me the value as 40. So you can basically use another thing also here. You can just basically write like this: the multiplication is, and then self dot a. So this was all about the multiplication Dunder method. Here I have used this special, oh, let me just show you that what if the value is not an integer value. So let me just say 2.2, and if I print it, okay, yes, it's showing me the next exception that the number should be integer. So that was about the multiplication part. And now let's move on to another part of another Dunder method, which is basically representation, or Dunder method, REPR Dunder method. So I'll just show you what I mean by it. So let me just create the Dunder method. It goes like REPR, and then self. Okay, so what does this representation or REPR method do? It basically is an unambiguous representation of the class. So let's say that basically, first of all, let me just comment this out, and I'll just show you the default representation of this class. So let me just print the value of c over here. Let me just comment this out. CLS. You can see that we have something like this: the underscore main dot person is my class name, an object at this value. So what this value is, this value basically is the memory representation of the class. So you can see that where the memory, what's the memory number or name or the representation where the class is stored. So it goes like, it goes something like this. So what so this is what we can say is the representation of the class is. So if you want to basically override the default representation of a class, so we go by this REPR under method. So I'll just show you in a bit. Okay, so I'll just say that okay, so I'll just say return a string, and I'll say the value is I want, okay, so I'll just say the value is self dot a. So now if you print the value of c over here, you can see the value is 20. I have just basically changed the default representation of a class, and we are not seeing that default memory value and the class name and the underscore main over here again. So that was how you can use the representation method, Dunder magical method. So let's move on, and now let's use another method which is called the length underscore method. So for the length, from the name itself, it must be clear to you that length basically it counts the number of characters present in a string, or yeah, basically in a string or in the given data type. So we'll just say def length. Okay, and now we'll just say self, and I'll just say okay return, and I'll just call a string the length is and I'll just print self dot a, and I'll just count the length. Alright, so now basically I have to just change the object which I entered over here, and it will be the data will be of string, and then only we can find the length of that string. And then basically I have just now changed the value of 20 to Satyat, and then basically I have just called my length function over here, and then I've asked to print the length of that string. So if I run it again, you can see that the value is Satyarth, and basically it's showing me the length. So that was all about the length underscore method. So the last important underscore method will be the call method. So we'll use just call method self, and now we'll just print we'll just say that you have called, and we'll just say oops, I forgot to give the external argument, so I'll say you just called y, and you just called y. Okay, so now let's say that let me call something. I'll just use the class variable c, and I'll just call let's say given integer value 20, and if I run it, you can see yes, it's showing me the value and the with the argument. So that was the all about the call the underscore method. So the last thing, guys, is that that this basically is interesting. So first of all, I hope you know about the queue data type. Sorry, the data structure. So basically, we'll just now are gonna work something for this. I know this video is getting a bit longer, but stay with me. This is a fun thing. So I hope, and I think that you will like it. I'll say just import queue. Okay, and now if I just basically queue, and if I call this queue, and if I print this queue, Let me just scroll the screen. You can see that the queue object has been created with the memory address with with the value of this. So there's a method, guys, which known as inspect ins yep, just like this, inspect. And now let's say that basically you want to basically inspect and get the source code behind the queue script or the queue data structure written in Python. So we'll just call this that inspect dot get source code. Sorry, it will go just get source, and we'll just print this. Okay, got Q. So it's showing me the trace back, the model class function. Okay, got Q. So it will be something like this. I hope this works. Okay, yes. So now guys, you can see that this is the source code behind the Q data structure written in Python. So let's say guys that you want to basically overwrite this Q let's say Q function or Q method, whatever you call it. So let's say that you want to basically override it. So for doing that, what we'll do is we'll just say that from Q import Q as Q, because here you can see guys that yeah, that basically if not if you look over here, then Q, then by default it is also imported as Q. So it's better that we use the by default thing, or you can basically define anything. You can say E W X Y Z anything, and I'm just using a Q. And now basically we'll just define a class. It goes like Q, which will have the Q as parameter. So now let's say we'll use the representation. Remember guys, the representation, which is the unambiguous or the default representation of a class. So we'll just call it and work with it. Just self. Okay, and now we'll just say return. We'll just use the f string. Okay, the size of the queue is, we'll just basically call anything, and we'll just say that self dot underscore, again I check it, it's yes underscore queue size. And now if I print the value of okay, first of all I have to create an instance. Q is equals to Q, and if I print this Q over here, if I can call it, let me just clear the screen. Okay, now you can see that the size of the Q is 0 because there's no element inside it. Still there's no element inside it, and but we have successfully basically changed the default look of the Q class. So now let's define a function which will add something in it. So and for doing that, we'll just use the add method. Sorry, this goes like this. Self and the item which we gonna add into it, and then we'll just say self dot self dot q. So that we just say self dot put and then put function, and then just basically we'll just add this item in it. We're using this put because that's how the queue works. Basically you just put some elements in it, and then for retrieving it or for subtracting it, you're gonna use the same item argument name. You can use anything, and I'll just a self dot get function, and I'll just basically do this. Okay, and now if we add something in our queue variable, we'll say q plus 10, q plus 11, and now if I print this, okay, the size of the queue is 2 because 2 elements are added in it. And now let's say that we want to delete the last element from it, so we'll just basically q minus none, and we'll say the size of the queue is 1, so the last element is deleted from it. So that was it about the queue based data structure basically. And similar to this, you can also basically override many other data structures. You can override the linked list or the DQ, and also the other data structure functions which you want to override. And remember this, guys, that the dot get source which I used over here, it was something like this: import inspect. Okay, let me just show you. Print, and if I say inspect dot get source, and if I call my uh, q class over here again, and if I see this, yes, now the source code has successfully been overwrite, and I have just basically rewrote the source code behind the q class. First of all, it before initially it was the default source code of the q class, and I just overwrite the source code of the q class. So, and for viewing any of the for source code of for any method or any script or any class, just basically use this inspect dot gets and get source and the method or class name. So that was it for the second tutorial, guys, and I hope this was a bit lengthy. I'm sorry for that, but I hope it was enjoyable for you. So if you like this video, please do subscribe to Code Initiatives, like this video, and share with your programmers friend. Till then, goodbye, take care, and keep coding.